Alright, so hopefully the PowerPoint that you've been looking at is making a little bit of sense. Here it is. Let me just kind of explain again. Once again, if you've got two equations that line up and your variables will cancel, then add them together. So straight up add up and down, so we get 7x. Add those down, that makes nothing. That's the idea behind elimination, is something will cancel. So if something cancels, great, you're in business. Add down 21. Look what baby equation you have left over. X equals 3. So I start right there with x equals 3, but I'm halfway through the problem. The x value is 3, so I put it in the spot where the x value is going to go. Okay? You're going to plug the 3 right back into one of the two original equations, just like in substitution. And the trouble here is you got to pick one of these two equations, and they're not going to be as easy as it is in substitution. So I'm going to pick, well, which one looks, this has smaller numbers over here, but that has a positive y. I like that. So I'm going to plug the 3 right here. Okay, so if I plug 3 in there, I end up with this equation over here. 9 plus y equals 14. And that's baby math. Just subtract the 9 over, and you get a y value of 5. So my solution to this equation is is 3 comma 5. Okay. Let's move on here. We saw that one. That's what we just saw. Okay. A couple more examples. Notice this one the y's line up, so that'll be nice and easy. This one the x's line up, so that should be nice and easy. Feel free to pause it and see if you can get that answer and that answer. Okay. Pause it and unpause when you're ready. Okay. So hopefully you got those two answers. And let's continue on. So, looking at this next system, see how, gosh, those y's don't cancel. But the x's are the same, but they're not the same. One's positive. They're both positive. So if they're both positive, that's not good. When you add them up, you get 12x. Well, that doesn't work. We need something to eliminate. So nothing canceled out. So instead, we're going to try to change one of these two equations. So as long as you change the entire equation, you can do it. It's legal. So I'm going to take this entire top equation times negative 1. So what's going to happen is the top equation will become negative 6x, negative 11y, positive 5. Like that. Did you see it? I'll go back and forward. Bang. See how the negatives appeared? Negative there and negative there. So when I add the two equations together, my x's cancel that time. Negative 2y, positive 2, divide by negative 2, and then that'll tell me what y equals. Okay, so y equals 1. Let's start right there. We're halfway there. I don't know if you can see that, but right down below it says the answer is something comma negative 1. Okay, so we're going to fill in the second spot here. So on the second spot, we just need to take the negative 1 and plug that back into one of the two equations. Now I don't care which equation you plug it into. I think it's going to be easier if you plug it into one of the originals. And looking at the originals, these are smaller numbers, so it'll probably be a little bit easier. So when you plug negative 1 in there for the 9, you get negative 9. Okay, add the 9 over, you get 6. And then divide by 6, you get x equals 1. So there's my solution. I don't know if you can see it right down here. It's 1 comma negative 1. Pretty easy. All right, last but not least. Nothing cancels, crud. But you know what? If I had a negative 3 right here, wouldn't that be awesome? Then my x's would cancel. But I don't have a negative 3 right there, so, gosh, you know what? Let's just take the whole top equation times negative 3. And now we'll put a negative 3 there. It'll make this a negative 6. It'll make this a negative 18. But who cares? At least the top or the x's will cancel. So do you see what I did in that last slide? Go back here. I put an arrow and I put times negative 3. I don't have my times symbol there. I don't know what happened to it. But times negative 3, that's going to allow the top equation to become that. So I do it right next door to the original. And so I'll draw an arrow right here and I'll put times negative 3 and I leave it right there. Okay, so now the top equation, and oops, I guess I can't erase that. The top equation and the bottom equation working together cancels the x's. This will become negative 3y. This becomes negative 24. And you guys know what happens next. That becomes x equals 8. Or, I'm sorry, y equals 8. So there's my y value. Notice it's a y. Okay, so the next one would be, we're going to plug that y back into one of the two originals. I would plug it into the top one. Yeah, top one looks easier. So I stick stick y right in there, 8. See how it becomes 16. Subtract the 16 over, it makes negative 10. There's my y value, or x value. So negative 10, comma 8 is where the two lines cross. Think about this. I'm saving a ton of time by not graphing this thing and having to guess where the two lines cross, because they're going to cross at negative 10, 8. Way the heck up here somewhere on a huge graph. So this is a lot easier way to find the answers. Okay. Try these two problems, and when you're done, you can check the answers. Just pause it right now, do both problems, and see if you can get the same answers. There's your two answers. Bye-bye.